So I am also trying to that you people will not bore, okay? So I will try my best. So today we are going to perform experiment without the equipment, and that is very interesting. Now the experiment is Francis turbine experiment, and this is me myself, Tariq Chaudhary, and I am from Mechanical Engineering Department. Now before going to start this experiment, I assume that all of you have these lab sheets, which no one of you, I think, bring in the class. So then the second thing I do by myself, checking the rig, because sometimes we have some issue. It's actually common lab, so other people are also using that lab. Another thing is extra equipment requirement. To find the speed of the turbine, we need something which is not available with the turbine. That is called tachometer. So I try to use bring with me as well. Now before going to start this experiment, I would like to give some introduction. So my first question is, what is turbine? Anyone of you? It's very common and you must have studied. Yeah, definitely you have studied in your class.
Yes.
Actually turbine is basically converts the fluid energy into mechanical energy. Like sometimes people call it water turbine, but it does not mean it's water turbine. It depends on the fluid you are using. If you are using steam, it's a steam turbine. If you are using gas, it's a gas turbine. But today we are using actually the water turbine because the working fluid is water. So we are going to utilize the water energy and convert into mechanical energy. Types. So, have you any idea about the types of turbine? There are two very common types. No, these are not types.
Okay.
Actually, the turbines works on some working principle. One is because of change in pressure and one is because of change in velocity. So one is impulse turbine and one is reaction turbine. The turbine which we are dealing is actually Francis turbine and it's a reaction turbine. So the force which is produced in reaction turbine, it is basically because of change in pressure. So Rusha already discussed what is pressure, so I am not going to discuss that. Now, what are the applications? Everyone knows, I think, about application. So, anyone of you?
To produce electricity wind turbines, for example?
Actually, it's used. I mean, one of the very common application is it's used to produce power in the power station, hydropower station. But there is another term, it's called as pump storage. So, instead of producing energy, we can store the energy as well with the help of turbine. If we reverse the cycle, it's much similar like pump. As the pump works, turbine also works on the same principle as the pump works. Now what is the aim? Aim is to find the maximum operating efficiency. Now basic equation and theory involved. You don't have the hand page that, but in the page there is an equation which is called flow rate. So to find this maximum efficiency, we need the water power, which is basically and to find this Q, which is basically a flow rate, we will apply Bernoulli's theorem across Venturi meter. Anyone knows about Venturi meter? Actually, it is a device which is used to find the flow rate. So actually, we are going to find this Q across this Venturi meter. What is Bernoulli's theorem? It's very common in physics and in thermodynamics as well, in fluids as well. P1 over rho into G plus V1 square over 2G plus Z1, but the board is small, sorry. P2 over rho into G plus V2 square over 2G plus Z2. So you have, how much? Okay. So you have 1 minute to write this equation, pressure on one side and velocity on the other side. I usually give more time, but we don't have such.
Minute, beautiful. What is the exercise again?
You have to write pressure on one side, like
Okay.
P1 minus P2 on one side and all the other parameters on the other side.
should I tell you?
Yeah.
So it's P1 minus P2
Yeah.
is equal to rho G
Yeah.
and bracket start. Then
Yeah.
it's 1 over 2G bracket open, V2 square minus V1 square.
That's fine.
Then plus, then you have say 2 minus Z.
Okay.
And then
Actually, this Z1 and Z2 will be cancelled with each other because when we have a Venturi meter, its level is horizontal. So basically, Z1 is equal to Z2. So in this way, we can simplify this equation, and by applying the equation of continuity, we can find the equation of load rate. We don't have that sheet, so I can go ahead. These are the different parts of the apparatus. It have a valve over here. This is casing, and this is the wheel where we apply the load, and this is the load. So procedure, I am skipping this. Now, when we find the value of static load, the value did not appear what the value we need. Any one of you can tell what could be the reason.
Is that you?
Yeah, this is it. I am not the reason for it. Okay, actually, what's going on? Sorry for the bad picture. No, I presented two pictures. One is this one. Over here we can see the load is available on the machine. And second is this one. On this picture, there is no load on the machine. So before going to start this experiment, we have to put some load on the machine. Otherwise, it will run without the load. I'm skipping other things as well. The last thing, which I learned from my previous experiment. When we did this experiment last time, we took about 10 observations. And we need one curve to find the maximum operating efficiency. And this is basically the maximum operating efficiency. And we cannot get this curve, some of the groups actually. So what I did this time, I increased the number of observations. We try to use a pressure difference between the different values, and we try to use now 2 psi. Last time we did this experiment and we used 3 psi difference. The maximum was 35 psi and the minimum was 10 psi. So we try to increase it. Another thing is the common issues with the long reports of the students. They don't write abstract, or they write in a wrong way. Like they just write the aims. What is actually abstract? It means what you are going to do, how you done this, and what you have found, and why your results are different. And there are some other issues, conclusion and references, that's all.
Thank you, Tariq. Tariq, I was going to ask a question. Thanks for that. That was really good. You've got a really nice, again, you've got a lovely voice, lots of energy, lots of enthusiasm for your subject. It's really powerful. It's really good. I love that you're asking questions for the class. If you're, which year is this?
This is actually the third year.
Third year, yeah. How many of them are good at working on that quickly? Just really
Equations?
first. Yeah.
Actually, I don't give 1 minute, but most of
Yeah.
them solve this equation actually.
Yeah.
Because this is a basic equation, and we suppose that in first year,
Yeah.
in fluid mechanics, they read this equation.
Yeah. They learn
And
that
same
first
thing
year.
about this one.
Yeah.
And then I ask from the students,
Yeah.
and they know this water power.
Yeah.
It's very common. I mean, if you want to
Yeah.
put
This is
the
about flow rate.
input energy,
Yeah.
so you must know this.
Yeah. Yeah, I was thinking with an equation, giving them 2 minutes, giving them a little bit longer.
No.
You can, again, you can.
No,
get
actually,
it quicker.
it's only because of 8 minutes.
Yeah, that's fine.
So
That's
actually,
fine.
you're not like this. I give them 5 minutes
Yeah.
to read the lab sheets as well.
Yeah, thanks very much. That's great. Thank you. I only, yeah, I just ran out of time a little bit working out that equation. He says.
You need 2 minutes?
I need 2 years. In fact, you know, my uncle was a maths teacher, and he just despaired of me. So there was one thing I couldn't do. It was, well, there was quite a lot of things I can't do. One of the many was maths for some reason. And it was funny. I was sitting with a friend of mine, and I was drawing, because I'm very visual. I was drawing things and diagrams. And he said, "Oh, you would have been good at maths." And I said, "Really?" And I said, yeah, look at the way you're thinking. And I went, it's the first time anyone's ever said I could have been good. Isn't it? Things that you fall into. But, okay. Right, sir.